Welcome. Over the next 18 episodes, we're going to take apart the one engine that every neural network, every single one, runs on. Not attention, not transformers, not the fancy stuff. The thing underneath all of it, optimization. The loop that turns a pile of random numbers into something that works. And here's the thing nobody tells you up front. That loop is almost embarrassingly simple. It's one move, repeated. Measure how wrong you are, take a small step in the direction that makes you less wrong, repeat, that's it. That's training. Today we build that loop from scratch on the smallest problem that still shows everything. And we watch the error fall. Let's kill the biggest myth first. People hear the model learns and picture something understanding, a little mind in there figuring things out. It isn't. A model is a bag of numbers, we call them weights. And learning just means nudging those numbers so the output gets closer to what we wanted. No insight, no aha, just a number that was 0.0 becoming 0.50, becoming 2.9, because each nudge made the error a little smaller. Today, our entire model is exactly one number, W. Watching one knob move is the whole story. A billion knobs is just this in parallel. So, how do we know if a number is good? We need a score. That's the loss. One number that says how wrong we are right now. Low is good, 0 is perfect. Our toy loss is LW. 3 squared. It's a parabola, a smooth valley with its lowest point at W loss up to 3. The common misconception here is that loss is some abstract grade. It's not abstract at all. It's a height. Picture the valley. Where you stand left to right is your W, and how high up you are is your loss. Training is just walking downhill in that valley until you can't go any lower. Now, the misconception that trips up almost everyone. To find the lowest point, can't the computer just look at the whole valley and jump there? No, it's blindfolded. At any moment, the optimizer knows only two things: where it's standing and which way the ground tilts right under its feet. That tilt is the gradient, the slope. For all loss, the slope is L, W, 2 to W, 3. Stand at W, pull is 0, and the slope is 6. Ground falls off to the right, so right is downhill. It never sees the bottom, it just keeps asking which way is down from here and shuffling that way. Here's the rule we shuffle by, and it's the heart of the whole course. New W, old W, learning rate x slope. Step against the slope, uphill slope means step left, downhill slope means step right, by an amount set by the learning rate. We'll use 0.1. The misconception, people think you subtract the slope itself. You don't. You subtract scaled slope. The learning rate is the size of your stride and it matters enormously. We'll spend a whole episode breaking it. For now, 0.1 gives us a nice calm walk down. Watch one step concretely. Start at W, occurs 0. Loss is 0.3 squared, 9 way up the wall. Slope is 203, occur 6. Apply the rule, W about 0.1x or 6, 0.6. We moved right toward the bottom, and the new loss is 0.63 squared, north 5.26. Lower, that's a successful step. Nothing clever happened. We just read the tilt and leaned downhill. The intelligence people imagine is this several billion times. And here's the satisfying part. The steps shrink on their own. Far from the bottom, the slope is steep, so you take big strides. As you get close, the valley flattens, the slope shrinks towards 0, your strides shrink with it, and you glide gently into the minimum instead of overshooting. Nobody schedules that, it falls out of the math. Big steps when you're lost, tiny steps when you're nearly home. By step 50, our W is 2.99, a hair from the true 3, and the loss has collapsed to 1/10,000th. One more myth before we code, that the loss should drop in a straight line. It doesn't. It drops fast then slow, a curve that plunges early and crawls into a long flat tail. That tail isn't the model being stuck. It's the model being nearly done, polishing the last decimal. When you train real networks and the loss curve goes flat, that's usually this. Diminishing returns near the bottom, not a bug. Learn to read that shape now. You will stare at it for the rest of your career. Let's build the loop. One file, zo1 learning loop.py, about 40 lines. We define the loss, define its slope, set a starting div and a learning rate, then run our for loop 50 times doing exactly one thing each pass. Read the slope, take the step, we log every step, and at the end, print where we landed. No libraries doing the thinking, just NumPy holding the numbers so you see every moving part. First, the two functions that are the problem. Loss W returns W 3.2, our height. Grad W returns 2, W03. The slope, the hand derivative of the loss. That's the only calculus in the episode, and we did it by hand, so nothing is hidden. Everything downstream just calls these two. Now the setup, W 0.0, our starting guess, deliberately far from the answer, so the descent is dramatic. LR 0.1, the stride length. Steps 50, and an empty history list so we can plot the curve afterward. Every step W loss we touch goes in here. The loop, 6 lines that are the entire field of optimization in miniature. Each pass, compute G os grad W, the local tilt, record the current loss, then the one line that matters, W os or W, LRG, that's the update rule from scene 4 verbatim. We print the step, the new W and the loss so the terminal tells the same story the figure will. After the loop, we print the final landing, W tower on 2.99900, loss, bar 0 do, zozo 1 dot, and dump the history so the plotting code can draw loss against step. Notice we never told it the answer was 3. We only ever told it how wrong it was and which way was down. It found 3 by falling. Blast, and that's training. The whole thing, honestly. A score, a slope, and one repeated step against it. Everything else in this course is making this loop faster, steadier, and able to survive on messy, high-dimensional landscapes. But the skeleton never changes from what you just saw. Next episode, we zoom all the way in on the one piece we hand-waved today, the slope itself. Where does the gradient come from? What is it really telling you? And why is it exactly the direction of steepest descent? That's OP022, gradients, the slope that points downhill. See you there. And that's training. The whole thing, honestly. A score, a slope, and one repeated step against it. Everything else in this course is making this loop faster, steadier, and able to survive on messy, high-dimensional landscapes. But the skeleton never changes from what you just saw. Next episode, we zoom all the way in on the one piece we hand-waved today, the slope itself. Where does the gradient come from? What is it really telling you? And why is it exactly the direction of steepest descent? That's OP022, gradients, the slope that points downhill. See you there.